Let me see. Okay, let us wait for 5 minutes. Let others also join. हाँ बोलिए.
सर मैथ क्लास के लिए सर आपने ऑनलाइन के लिए बोला था.
हाँ मैंने भेज दिया है लिंक.
सर लिंक नहीं मिला था सर.
अभी अभी भेजा है मैंने, देखो.
ईमेल पर.
हाँ वो मेल पे ही आया होगा.
ओके.
Let others also join. So I'm just waiting for everyone to join. Okay, so I think we have 1, 2, 3, 4, 5, 6, 10 people, 11. Okay, I think most of you have joined. Okay. Okay, has everyone joined now? Uh, can you see the full screen now?
Yes, sir.
Okay. Okay, 1 second. Let me just check. Yes.
सर वो बात हो गई थी अंटेक्स में से या आप लिंक भेज रहे थे?
मैंने भेज दिया लिंक, सबको भेजा है।
ठीक है।
हम्म। Okay, so good morning, everyone. How many of you are there on campus? कौन अभी मतलब जयपुर में नहीं है? आदित्य, भूपेन, ऋषिकेश, कृष्णकांत, मोहम्मद फैज, मोहित, प्रतीक्षा, राहुल, हर्ष, रविंद्र, सत्येन, सौरभ, सुदेशना, उदित, विजय, विशाल। आप लोग कितने लोग हैं अभी जयपुर में और कितने लोग बाहर हैं जयपुर के?
सर मैं बाहर हूँ।
मोहम्मद फैज।
सर आई एम
कृष्णकांत
सुदेशना,
आप?
मैं बाहर हूँ।
ओके, कृष्णकांत, सुदेशना एंड और कौन है मींस?
मैं तो जयपुर से ही हूँ।
अच्छा, बिकॉज आई थिंक यू रेज योर हैंड, रविंद्र मिश्रा, सो यू आर आल्सो आउटसाइड?
Yes, sir.
And regarding exams, have you received any notification, anything like now about next semester? अभी आपके पास कोई what is the latest information you have?
सर अभी तक क्लास के लिए ही आया नोटिफिकेशन, एग्जाम के लिए नहीं आया।
ओके, तो और आपको नेक्स्ट सेमेस्टर का कुछ हुआ है कि नेक्स्ट सेमेस्टर कब से स्टार्ट होगा?
No,
ओके,
नो सर।
no, sir.
बट इनिशियली जो आपका एकेडमिक कैलेंडर था उसमें क्लासेस आपकी ये कब 18 तक था, 17 और उसके बाद एग्जाम्स था? व्हाट वाज द इनिशियल कैलेंडर दैट यू रिसीव?
सर
17 तक
27
था सर, 24 से एग्जाम।
24 से एग्जाम। तो आई थिंक अभी जो है शायद ये होगा कि दैट exams will be held in offline mode. One second. So exams will be in offline mode and maybe as and when situation for, but offline के लिए क्योंकि आप लोगों को जो लास्ट नोटिफिकेशन गया था that was regarding offline classes, right?
यस सर।
So, because already we are assuming, or it is being assumed that you are there offline for master student at least, because the notification that was sent earlier that was for the offline classes, and I think some of you approached me regarding that classes because some are unwell and some could also not come to Jaipur. So that's why we are having this online class. Otherwise, from academic section, we have the instruction to conduct the offline classes. And in fact, there is a delay from my side because for mathematics, at least for this course, I wanted to have offline class. So, however, since some of you cannot join and due to some reason, um, at least I'll be able to give you an overview of what is left. Uh, this is not going to be as effective as in a offline mode. So what I'm trying to do is because the one thing is like as I said told earlier that this course there are three modules. So we have covered module one, module two. Now remaining is module three. And if you look at the contents of the course, so basically, let me just open the syllabus once again. One second. I'm just opening so that first let us review that what we have done till now and what is remaining so that we can plan accordingly. So let me open the syllabus. Just give me a second. One second. So I hope you can see this file, right? PDF file. So let us review what we have done till now and what is remaining for this module 3. So let me go to this page. So I hope you can see this page, Advanced Engineering Mathematics, this syllabus. Can you see the screen?
Yes, sir.
Okay. So as I was saying that if we look at this complete syllabus for this course, what I had tried to do was divide this in three modules. So linear algebra vector and this, so till this part is what we have already done. Mises power eigenvector. So this was in your module one. Now and then we started after this topics in numerical method, solution of nonlinear algebraic equations, system of equations, interpolation methods, and till this part, this is your module three. So module 1 and module 3 has been covered. Only thing in module 3, like Laplace transform method for non-homogeneous linear second order ODEs, discontinuous right hand side. So this I had not covered because this we will also be doing in next semester, where we have this modeling and simulation of dynamic systems. So this part I will be covering in another course. And this is just like here we are talking about the solution of ordinary differential equations. So more or less we have an idea for this. So module 1 is covered, and then module 3 is covered. Now remaining is your module 2, and this was about tensor algebra, index notation, vector and tensor calculus, curves and surfaces, gradient, divergence and curl, line, surface and volume integral, Gauss-Stokes and Bayes theorem. So these are three, four topics that are remaining now and which is to be covered. So this is what is remaining now: tensor algebra and index notation. And then tensor calculus. Then in calculus, tensor calculus, we cover about this curves and surfaces, gradient, divergence, and curls. These some theorems. And since you are already doing this course on theory of elasticity and plasticity, and in the next semester you will be doing this course on finite element method. So basically, there you will be using this part, that is the module 2. Now let me come back to the mm, presentation here. So this is the outline for today's lecture, and this is what we are actually we need to cover in the tensor part. So you already have some idea of like what is a tensor, because what are the courses that you are doing in this semester, masters to those, because we have PhD student also. So this question is from MTech student. What courses you have done in this semester?
So theory of elasticity,
Uh,
experimental stress analysis,
hmm,
dynamics and
hmm,
vibration.
hmm.
So
So any idea anyone can say about like tensor? So you must have covered something about tensor. So because this module we are trying to talk about tensor and tensor calculus or tensor algebra. So you have any idea about what is a tensor or what do we mean by tensor? Anyone would like to say anything? Or how is like you already know about scalar and vector. Now moving ahead, then why we need to introduce another topic? What we are saying is tensor. So what exactly is a tensor? Anyone would like to say, or have you heard of this term?
Yes, sir.
Yes, sir.
So can you say what it is?
The tensor is a physical quantity which represent direction, magnitude,
And
Okay,
plane.
and the plane on which it acted.
okay. So you say that it is a physical quantity, uh, and anything. So again, like for scalar, you said that it is magnitude. Then vector, we are saying magnitude and direction, and then you are saying that it is a physical quantity, and again it could be like magnitude, direction, and plane. Also, you are
Plane.
trying to add to this term. And anything to do with the coordinate system? We have also, so okay. And what kind of physical quantity? So any physical quantity, or like because you said this word physical quantity. So does it imply that it could be any physical quantity, or what do we mean by this physical quantity? Yeah, so who gave me the first definition? So if I can, because I cannot see, I have another screen open here, so uh, I'm not getting the names out there. So if you could just read out, tell your name and then again repeat the definition that you said for tensor. हाँ जी, कौन था? Am I audible? What I'm asking is someone discussed this definition of tensor. So who was it? Can you just tell your name?
Yes, sir. I am Satyam Singh, sir.
हाँ सतीन. हाँ सतीन. तो आपने बोला था it represents a physical quantity. So my question is that when you are talking about physical quantity, so what kind of physical quantity are we addressing? आपने जैसे स्ट्रेस टेंसर के बारे में सुना है, तो अब स्ट्रेस कैसे फिर फिजिकल क्वांटिटी होगा? बिकॉज द फर्स्ट वर्ड दैट यू सेड वाज दैट इट रिप्रेजेंट्स अ फिजिकल क्वांटिटी. एम आई राइट?
Yes, sir.
कैन यू से द डेफिनेशन वंस अगेन?
Sir, just I say that tensor describes the direction, magnitude, and the plane on which it's acting.
नहीं नहीं नहीं, उससे पहले आपने फिजिकल क्वांटिटी वर्ड यूज किया था. नाउ यू आर स्किपिंग दैट
Sorry.
वर्ड. So, does it refer to physical quantity? That is what I'm asking. अच्छा, आपने पहले फिजिकल क्वांटिटी वर्ड यूज किया था या नहीं किया था? चलो ये बताइए
किया
आप
था
एक
सर.
बार. हाँ जी.
Yes, sir. किया था सर.
हाँ, so it is not wrong. So we are just trying to get into that part because one tensor that you have heard of is a stress tensor. So my question was that if we are starting, if like you said that it represents physical quantity, and of course we understand magnitude, direction, and plane also. Maybe vector does not talk about the plane, and so tensor here we are saying that it also refers to the plane. So my question was when you are saying a physical quantity, so what is that means what kind of physical quantity? And then the other question was when we say like one tensor that you have heard of is stress tensor. So whether this stress is a physical quantity. So that is what we were trying to discuss.
Right, sir.
ओके. अच्छा, बीच में एक और चीज है. सो रिगार्डिंग योर आंसर शीट्स आई हैव शेयर्ड द मार्क्स लिस्ट एंड few students had approached me yesterday. They wanted to see their copy. तो कल मैंने नहीं दिखाई थी. तो will you be able to take the classes in offline mode from next Monday? Can we have classes in offline mode next week? Means एक हफ्ता ही मतलब 24 से तो एग्जाम्स ही हैं. मींस एग्जाम हो गया नहीं, दैट आई एम नॉट श्योर राइट नाउ, बट कैन वी हैव ऑफलाइन क्लासेस फ्रॉम मंडे?
Okay, sir.
So during the offline class, then I can show you the copy. और जो अभी जयपुर नहीं पहुंचे हैं तो वो बाद में फिर वो देख सकते हैं. और बिकॉज आई थिंक दैट 3 या 4 जनों को छोड़कर बाकी सब है. तो आप लोग जो लोग अभी नहीं जयपुर आए हैं, सो फ्रॉम नेक्स्ट वीक वी विल हैव ऑफलाइन. Today it is more of a introductory class so that you have an idea that what is being left out और वो क्या करना है. So I may not be covering the entire thing today, but just give an overview of what we have to do next. And maybe in the offline class, then we will have a detailed discussion of this topic. और उसी टाइम आंसर शीट्स भी जो है आपकी, so you can see over there. So coming back to the topic about the tensor, तो एक तो ये है कि जो आपके कोर्सेज हैं थ्योरी ऑफ इलास्टिसिटी एंड प्लास्टिसिटी या फाइनाइट एलिमेंट मेथड, तो ये जो ग्रेडियंट डाइवर्जेंस जो टेंसर कैलकुलस की जो बात कर रहे थे या इंडिकल नोटेशन की जो बात कर रहे हैं, सो दीज आर सम थिंग्स दैट वुड बी यूटिलाइज्ड इन योर अदर कोर्सेज. So as such, what we are talking about is that these concepts would be applicable in other courses. So getting back to this definition for the tensor, and even like when we are talking about this continuum mechanics, so we have to understand tensor. And टेंसर की बात करें तो उससे पहले स्केलर वेक्टर also needs to be reviewed. So you have already have some basic understanding about this. Now, one thing that I was also talking about when we discussed about this tensor, so we said that if we are talking about any quantities, so if we are referring to any physical quantity, so we said that what happens to that quantity when we are talking about a coordinate system. So I think you can see the next slide here. So on the next slide, where we are talking about what is a vector and how do we show something as a vector. So in this slide you can see that when we are trying to define a vector, so if this V is a vector here, I hope the slide is visible. You can see the slide?
Yes, sir.
Okay.
Yes, sir.
So we are saying, say this is a vector, right? And when we have to, so again, our understanding is about tensor, or what we are trying to cover in today's class would be tensor, but we are having some basic review because some of the concepts that are related to vectors would be used in the tensor. So when we talk about a vector or when we define a vector, so we talk about its component and the basis vectors. Now what is the component and basis of a vector? So if we look at this vector, and maybe so when I am trying to define this vector, so this is a Cartesian coordinate system. We are looking at Cartesian coordinate system where the three coordinate axes, that is your xyz or x1 x2 x3 as being represented in this case, so these are mutually perpendicular, right? So this is the Cartesian coordinate system, and we have one vector v which is defined in some Cartesian coordinate system. Now if I look at the components of this vector v, so in terms of this coordinate axis, so I can, or what we generally look at is the projection of these of this vector onto different axes. So what are the components of this vector? And the other thing is that the basis vector. So if I have to like write down this vector, so I can write it in terms of its component and the basis. And this is what you have already done or you already know about. So earlier maybe we used to we have used this notation I, J, and K, right? Now the next question is that when we have already used this notation I, J, and K, so what is the point of using say E1, E2, and E3? So here in this slide you can see like it is written as E1, E2, and this I think should be E3 here. So this is a spelling mistake. So this is E1, E2, E3. So one thing is that now when earlier we have used these components as I, J, K or unit vectors. So why we are using another notation that is E1, E2, E3. Then second thing is you are also looking at some
Sir,
kind of a coordinate transformation. So
excuse
so
me,
what
sir.
we are trying to look at is that we have defined this vector V in one coordinate system and which is
सर
having basis. Yes.
सर
सर वो
स्लाइड
स्लाइड
2 पे
चेंज नहीं
ही
की।
पहुंच रुका है।
ये स्लाइड आप कोऑर्डिनेट सिस्टम यहाँ इस पे देख पा रहे हैं कौन सी स्लाइड
यस
है?
सर।
स्लाइड 2 पहुंच रखा है, 2 पे ही है।
What is a vector, sir? Exactly.
हाँ तो मैंने अभी चेंज नहीं किया है, मैं इसी फिगर को ही एक्सप्लेन कर रहा हूँ.
सर फिगर नहीं आ
You
रहा
can
है,
see
ए
the
प्लस टू
pointer,
बी
right?
प्लस बी लग रहा है।
Laser pointer you can see on the slide which is moving. ये रेड पॉइंटर दिख रहा है आपको इस स्लाइड पे?
नो सर।
नो सर।
वेक्टर की स्लाइड आ रही है सर, व्हाट इज वेक्टर वाली?
No, sir.
हाँ, what is vector वो ठीक है, but can you see the pointer also, laser pointer when I am moving this pointer?
नो सर।
No, sir. No, sir.
One second. Uh, now at least can you see the cursor? कर्सर दिख रहा है आपको?
No, sir.
नहीं सर।
What is the slide? What is a vector? How do you show that something is a vector? This is the slide we are talking about, right? ये slide आपको दिख रही है on screen?
Yes sir, what is vector is shown.
What is the
Okay.
vector?
And you can see one figure here with coordinate axis x1, x2, x3.
नो सर।
सर ये स्लाइड थर्ड में है।
सर वो स्लाइड
एक
थर्ड है।
सेकेंड, let me
स्लाइड
see.
थर्ड है सर वो।
इसमें
Yes sir, now.
Yes, sir.
नाउ इट्स विजिबल।
okay. But why it is not visible in the full screen mode? Now, is it visible now?
Yes sir.
यस सर।
Yes, sir. Yes, sir.
And is the laser pointer visible now? Laser pointer दिख रहा है क्या?
नो सर।
Okay. So maybe laser pointer doesn't work. But you can see this figure with the coordinate axis x1, x2, x3.
Yes sir.
Okay. तो इससे पहले ये फिगर, ये स्लाइड नहीं थी क्या?
No sir.
So इससे पहले ये वाली स्लाइड थी. What is a vector?
हाँ सर।
Okay.
लिखा है।
So actually I was
Definition वाली
talking-
थी.
now has it changed? How do you show that something is a vector?
Yes sir.
यस सर।
Okay. So actually I was talking about this particular slide here. So before defining a tensor, so what is we are trying to look at is दो चीजों की हम बात कर रहे थे. एक तो ये आया था कि टेंसर फिजिकल क्वांटिटी. सो बिफोर एक्चुअली मूविंग टू अ फॉर्मल डेफिनेशन ऑफ अ टेंसर, सो वी आर लुकिंग एट कि ये जो टर्म्स है फिजिकल क्वांटिटी की अगर बात करें तो क्या टेंसर फिजिकल क्वांटिटी को रिप्रेजेंट करता है या नहीं. Like one example that we have looked at for tensor is a stress tensor, and you say that a vector, it is having a magnitude and direction, and a tensor, for example, if we talk about the stress, so you are also say it is important to define that on which plane it is acting. So in addition to the magnitude, direction, you are also talking about what is the plane. So moving forward, we said that okay, let's again go back to our basic definition of vector. And here we were saying that earlier when we defined a vector, say v, which is shown by a yellow line here in the slide. So if I try to define this vector, so we said that it can be defined in terms of its component and the basis vectors or unit vectors. And earlier in vector notation, we have used this notation that is I, J and K, right? So you had written a vector in terms of its or unit vectors, that is component along I, component along j, and component along k. And we are talking about the Cartesian coordinate system here. So point is that in this slide, then you see instead of using this coordinate as ijk, we are using this as e1, e2, and the third one should be e3. So why we have to move from ijk to e1, e2, e3? That is one thing which you have to keep in mind, because we will be using this particular notation. And so there is a significance that why we have changed from uh, ijk system to e1, e2, e3 system. So again, this represents the basis vector. And the point is that tensor, now we are talking about some kind of notations or summations that we will be using throughout the other courses. तो एक तो ये समझ में आ रहा है कि जब हम ये e1, e2, e3 ले रहे हैं, so I can have some index, say I, and then if I give the notation that is I1, 2, 3, so it becomes easier for me to define instead of ijk. So that is one thing. Then other thing is that uh, when we move from one coordinate system to other coordinate system, like e1, e2, e3 is one coordinate system that has been selected over here, and now I rotate this coordinate system with certain angle, and I get another coordinate system that is, say, e1 dash, or like x1 dash, x2 dash, and x3 dash. So what happens to the vector in the other coordinate system? So my question is, हमने एक वेक्टर v डिफाइन किया एक कोऑर्डिनेट सिस्टम में, जो कि था x1, x2, x3, राइट, जिसके बेसिस वेक्टर थे e1, e2, e3. अब मैंने इस कोऑर्डिनेट सिस्टम को रोटेट कर दिया, तो न्यू कोऑर्डिनेट सिस्टम जो है, so that is given by x1 dash, x2 dash, and x3 dash. Now the question is, what happens to this vector v in the new coordinate system? हाँ जी
सर डायरेक्शन कोसाइंस चेंज हो जाएगी ना सर?
ठीक है, डायरेक्शन कोसाइंस चलो चेंज हो जाएंगे. सो व्हाट हैपेंस टू द वेक्टर? Vector remains the same, but the notation or representation becomes different. That is what you want to say?
Yes.
क्वेश्चन
No,
सिंपल
sir.
है कि एक कोऑर्डिनेट सिस्टम में हमने वेक्टर डिफाइन किया, ये वेक्टर v है, इसको हमने डिफाइन किया इस कोऑर्डिनेट सिस्टम x1, x2, x3. अब मैंने कोऑर्डिनेट सिस्टम को इसको रोटेट कर दिया, और न्यू कोऑर्डिनेट सिस्टम है x1 dash, x2 dash, x3 dash. So now I have, if I have to define the same vector v in this new coordinate system, so you said that direction cosines would change. So that means, so we are saying that the something remains same, that is the vector remains same, but the representation would actually be different, right?
Yes, sir.
Yes, sir.
Okay. So we are saying that what happens to the representation or notation of this vector? So this actually gets different, but the vector itself, so this cannot change, or this remains the same. So this is what we are trying to address when we talk about this. So there are two things that we are going to highlight or cover in this. So one is like why we went from this ijk to e1, e2, e3. So this is what we call as the indical notation. So in the next slide, where you see direct and indicial notation. So other thing is that we are trying to use is a different kind of notation, which is called as a indicial notation, and we try to compare with like what is a direct notation. So we move to further, that is what is direct and indicial notation. So one is the direct notation, which is also called the invariant representation. इनवेरिएंट रिप्रेजेंटेशन का मतलब अगर हम कहें सो लाइक व्हेन वी आर टॉकिंग अबाउट coordinate system, and we said that if we define a vector in one coordinate system and then if we are trying to take another coordinate system, so naturally there would be a different representation, but the quantity would remain the same. So we are saying that this direct notation, it is also called the invariant representation. We'll talk about in detail what is this invariant representation. So you have also heard of this term stress invariant. So what exactly is that invariant or invariant representation that we want to look at? Then, as it was said that these tensor, they represent physical properties. Now, what kind of physical properties such as mass, velocity, stress that do not depend on the coordinate system? So, if I talk about a mass or velocity or stress, so this would be kind of independent of the coordinate system. So, we had seen in the previous slide that if we change the coordinate system, so if you were talking about a vector, so the representation of that vector would change. Like you said that the direction cosines changes. So what we want is that it should be possible to represent tensors and the operations on them without reference to a particular coordinate system. तो जैसे हमने देखा कि when we rotate or we change the coordinate system, so the representation of that vector changes. But tensor, as we are saying that it represents some physical properties, so whether it is mass, velocity, or stress. So these physical quantities, these are actually independent of the coordinate system. तो mass अगर कोई value है, so irrespective of the coordinate system, it would remain the same. So what we want is we want to have a representation that would be used to represent tensors and the operations on them without reference to a particular coordinate system. तो अब तक जो हमने जो रिप्रेजेंटेशन की जो बात की थी, so that was with reference to some coordinate system. Now we are saying that when we are talking about these tensors or some physical quantities, that is tensor, so these are independent of coordinate system. So whether we talk about these quantities or tensors or any operations on them, so we have to do it without reference to a particular coordinate system. So such a notation exists, and this is called direct notation, or what we say as invariant notation. And direct notation provides a symbolic representation for tensor operation, but does not specify that how these operations are actually performed. So we'll talk about that what is the symbolic representation and what kind of operations or how these operations are actually performed. Then there is something called as indicial notation. So like when we talk about tensor and then tensor before like in syllabus you had looked at this word tensor calculus, so there is also tensor algebra, which actually refers to any operations on the tensor. So if we have to perform any operations on the tensor, so they have to be projected onto a coordinate system where they can be represented in terms of their components. तो जैसे वेक्टर्स के लिए हम बात कर रहे थे कि कंपोनेंट्स और बेसिस और यूनिट वेक्टर्स, तो ऐसे ही टेंसर के लिए हम बात कर रहे हैं दैट दे हैव टू बी represented in terms of their components, and we need to have some kind of a coordinate system where they can be represented in terms of their components. And the representation that is used or the explicit representation of tensors in terms of their components is called as the indicial notation. So quickly we will have an idea to look at that what is this indicial notation. And as I said, like when we are using this system like E1 into E3, so what is that? What is the free index? And so that is what we are going to look at. In indicial notation, further we are saying the spatial directions are denoted by indices attached generally as subscript to the symbol, and number of indices is called the rank of the tensor. So let us. So these things again indicial notation, this is a topic that we need to cover in detail. And as I said that in this class, I'll just give you an overview कि हमें आगे करना क्या है. So if you are not able to get the things properly, it's okay, because I also do not have the complete material to put on the slide because I was not prepared for this online lecture. So we'll just have an overview and then we'll try to understand the things in detail. Moving further, so what we have talked about is direct notation, indicial notation, and then the third thing is range and the summation conventions. So range and summation convention is like when we
सर स्लाइड चेंज नहीं हो रही.
अभी चेंज हुई क्या?
नो सर.
No, sir.
Okay,
Okay,
so
sir.
I think there is some kind of lag or connectivity. अब ये range and summation convention दिख रहा है?
Right,
Yes,
sir.
please.
Right. Yes,
No?
sir.
Okay.
Yes, sir. Yes.
Okay. तो पहले ये थी डायरेक्ट एंड इंडिशियल नोटेशन. इसके बाद हम बात करें ये रेंज एंड समेशन कन्वेंशन की. तो रेंज एंड समेशन कन्वेंशन में यहाँ बात करें कि लाइक व्हेन वी हैव सिस्टम ऑफ इक्वेशंस, सो हाउ वी कैन राइट दीज इक्वेशंस इन कॉम्पैक्ट फॉर्म. सो बेसिकली अगर इन इक्वेशंस को आपको कॉम्पैक्ट फॉर्म में करना है तो जैसे ये a11 x1 a12 x2, and then when we move to the next row, so this is there is an index which is changing, a11 x1 a21 x1. So x1 x2 variables remains the same but the coefficients are changing, and this is like a11 a21 so on to an1, then a12 a22 an2. So if I had to write these equations in a compact manner, because we are talking about like how we are able to compute this, so I can represent these equations in compact manner in terms of I use some pre-index or some index. So I can write it here as ai1 x1 ai2 x2, because I is what is changing from first set of equation to second set of equation. So a11 a21, so if I can represent this a11 a21 an1 as ai1, so I is my index which is changing, and I takes the values from range 1 to so on to n. So we can write this compactly as ai1 x1, and this is called as the range convention. So what we are looking at is direct notation, indicial notation, then range and summation convention. So this particular thing is called as range convention, and here we are referring to some free subscript or a free index, because I is the free index as it is free to take on different values in its range, right? So further I can also take another index for this value of 1 2 so on to so ai1 ai2. So for this I can use another index, and I can have say another index as say j. So what we are trying to say is that further this can be compacted. So let me move to the next slide. So the system of equations can be written in a more compact form as aij xj bi. So I was your free index, and then we are using another index that is j for say 1 2. So that is for the row wise, and when we are moving column wise. So compactly we can write the system of equation as j1 2 n summation, and xj and bi represents your RHS. Now further, if you look at this, so when we are using this summation here, so this summation can also be avoided. So we have two kinds of index. One is the free index, and other is the j is called as the dummy index, and the whole convention that is being used. So this is called as the summation convention or Einstein's summation convention. And when we are writing it in this form of notation, so there is no need to further specify this summation. So we can simply drop this summation, because this is kind of implied here that if we are having indices like this, So there is one index which is repeating, and there is one index which is kind of free there. So we are saying that this summation can be avoided or dropped. And so what we are saying is that drop the summation sign, and we impose this rule that the summation is implied whenever subscript appears twice in a symbol group. So this whole thing is called as a symbol group. So j is appearing twice, and we had written summation for j 1 to n. So we are saying that when that index is appearing twice in a symbol group or product term, so the summation symbol can be simply dropped from there. So we can further write it in a compact form as aij xj bi. And this is called as the Einstein's summation convention, or Einstein's summation convention. Subscript j here is called dummy subscript or repeated index, which repeats in the symbol group. And this could be like, instead of j, it could be any other choice of the variable. So instead of ijk, I could write it as aik xk is equal to bi. So both are identical and valid. And choice of the index for dummy subscript. So j here is the dummy index or dummy subscript. So this is not important here. So we'll have like what we have tried to discuss is we will be covering these topics, that is vector, direct and indicial notation, range summation convention, and there are certain rules for this indicial notation representation. So in the physical class, we will actually start with these rules, that what are the rules for the. So I hope you can see the first slide for the contents, right? Can you
Yes.
see the first slide?
Yes, sir.
So in the next class, or in the offline class, we'll next look at these. What are the rules for the indicial notation representation? That is, we have talked about some indices and some conventions. So for equations, we had used that how we can drop the summation convention, or what is the range and summation convention. So next we'll look at the rules for indicial notation. Then we'll talk about what is Kronecker delta, and some of the basics for tensor calculus. And this will be, and then we'll try to relate it with the first module, or the module 1 of the course, where we have talked about eigenvalues, eigenvectors. So overall, what we have to look at is that how the things are connected, and how these notations or conventions would be used in different courses. So uh, in this particular class, what we have tried to look at is try to look at the tensor, that what kind of quantities are being represented by tensor, and what kind of operations we'll be using for tensors. Then what would be the convention or notations that will be used here. So we'll continue with this in the next class, and then in the you can also see your answer script. So I'll stop the meeting here, and I think in another 2 or 3 classes we will be able to cover these topics for the module 2. So you already have with you that what is to be covered in module 2. So I need some 3-4 lectures to cover the topics in the module 2. तो अगर जो लोग नहीं है, आपके syllabus हैं, topics हैं, तो you can also refer to a book and start reading these topics. So attendance, anyways, it is there. Okay. And in case there is anything, hopefully we should be able to do the class on Monday offline. Let's hope no one gets ill. Or अगर कुछ होता है, if you have to do online, so I'll need some time to prepare slides for this. So that will be informed. But as of now, Monday classes in the offline mode. अगर आपको और कुछ इशू आता है तो यू कैन इन्फॉर्म मी वेल इन एडवांस, मींस कल तक आप मुझे बता देना, बिकॉज टुमारो एनीवेज इज हॉलिडे, एंड सो देन वी कैन प्लान अकॉर्डिंगली. सो ओके, आई विल एंड द मीटिंग. इफ you want to ask anything or कुछ अगर discussion?
Sir, exam
No,
solve.
sir.
Okay. आप कुछ और कोई बोल रहा था ऋषिकेश? You saying something?
No, sir.
Okay. Okay, so thank you.